So here's video for 5.2.2, and so as we've moved along or progressed through the different ways of solving quadratics, we still have a couple more to go. So completing the square, this is one of the methods. So prior to this, in order to be able to find x-intercepts or to find some values in the table, we would just plug numbers in. Now for x-intercepts, we plugged in 0 for y to be able to solve. But that relied very heavily on us being able to factor. And we had a couple of problems previously. We couldn't factor. Completing the square is really a method that is going to help us when factoring fails us. So it's when we just can't factor. Completing the square will work. Well, sometimes it gets ugly, but it's going to work. It's actually really kind of nice. Now, the idea here that we definitely have to stick with is the fact that we are trying to make a square out of this. So I'm still going to use the generic area model that we've used before, or the rectangle that we've used before, but it has to be a square. So as a reminder, a square has equal dimensions on each side. So the base and the height are congruent to each other, the exact same size. We have to keep that in mind. So what we're going to do is we're going to try to build a square. The thing that normally causes problems in these type of situations is the constant. So I'm going to take a look at the problem itself, and I'm going to find the constant. And that constant here is a positive one. Ideally, what I like to do is just get it out of the way. So I'm going to take that and I'm going to move it to the other side of the equation. Now, to do that, we would have to subtract 1. So that's what I'm going to do. I'm going to minus 1 on each side. So I'm moving the constant just so ultimately, for the time being, I can just ignore it. Now, I'll deal with it later. I'm just not going to deal with it now. Okay, now that I have the x squared and the x, now I'm ready. I am going to use the x squared and the x to try to build a square. So not an area model that's a rectangle, but an area model that's actually a square. So let's go ahead and get that area model out. I want it to be equal dimensions, so I'm going to try to make sure that it looks like a square. Okay. Now, setting this up, we know that we would put the x squared in the bottom left-hand corner. Now, previously, we would need to know the constant. However, if this is a square, knowing that these two opposite corner boxes where the x's go, if this is a square, then the entries inside the purple boxes have to be identical. And we know that what goes in here are the x's. So I want you to go back and take a look at how many x's you actually get to play around with here. And it looks like it's 6 x's. So what we're going to do is we're going to take that 6x and we're going to split it in 2 even pieces. So I'm going to take that 6x inside, and I am going to split it in half, perfectly in half. That is going to give me 3x. That's what's going to go into the x boxes. So I'll put a 3x here, and I'll put a 3x there. Okay, so now let's go back to the whole patterns that we used previously. So we're kind of roping in some old stuff that we did. We know that when you multiply the diagonals, so if I multiplied that diagonal and I multiplied this diagonal, you have to get the exact same thing. Okay, well, I don't know what the first diagonal is, but I do know what the second one is. So if I multiply the diagonal of 3x and 3x, that diagonal is going to give me a 9x squared. So we need to figure out what has to go in the top right box to make a 9x squared. So I still need a 9x squared there. Well, just so happens that it's got to be a 9. Now, we push the constant to the other side, so this constant is new. This is not something that we had before. This is something that we had to come up with. So that one's pretty special. So that 9 right there, that was an entry to this that wasn't here before. Okay, so I made a square. All right, let's go back to the question. So I have x squared plus 6x equals, well, back to the question, -1. Okay, now at this point, I want you to take a look at the big, huge square that we just made on the right-hand side. You'll notice that the x squared is in there, check. You'll notice that the 6x is in there, check. But we just included something that wasn't, and that's the +9. Now, I would like that in there because then I could factor the left-hand side. So let's go through and let's actually get that +9 involved here. So I'm going to add 9 on the left-hand side. So I can actually create the square that I've got over there. So that's x squared plus 6x plus 9. So that's what I have inside the boxes. Okay, but this is technically an equation. Whatever you do to one side, so those 9 singles that I just came up with, you're going to have to add it to the other side as well. So I think that's going to give us 8. All right. Well, it doesn't look like the same question. However, if you decided to kind of play around with this a little bit and you subtracted that 9 to the other side, you'd get the -1 that you had just a second ago. Okay, but we don't want to do that because it's going to send us backwards. All right, now going back to the boxes. The reason why I did this was so that I could create a factorization of some sort. So let's go ahead and pull our stuff out here. I know that I can take an x out of the bottom. I can take a +3. I can also take an x and I can take a +3. Notice that the base and the height are identical, which they should be because you made a square and not a rectangle. So let's factor this now as x plus 3 squared. Drop down the equal sign and drop down the 8. Oh, now it looks like a question that we just did in the previous notes. So from here, I am going to try to get the x by itself. All right, well, I've got a +3 that I'm going to have to deal with. I have parentheses I'm going to have to deal with, and I have a squared that I'm going to have to deal with. All right, let's start peeling them away. So let's get rid of the squared first. So to get rid of the squared, let's write down what we have here. So I'm going to get rid of that squared since it's the thing that's the furthest on the outside. Well, to get rid of it, I'm going to have to square root both sides. Remember, plus or minus in front of that 8. Okay, on this side, the square and the square root cancel. This is good. So I've got parentheses x plus 3 equals, all right, plus or minus. Well, think about what we did in the last one. We can simplify the square root of 8. So I'll do a little work off to the side here. I know that 8 is the same thing as 4 times 2. This is useful because I know the square root of 4. And that's going to give me 2 times the square root of 2, which is 2 root 2. All right, let's replace that. So this is 2 square root 2. Okay, now assess the situation. I don't think I need the parentheses, like, at all. So those parentheses right there around the x plus 3, those are no longer necessary. So let's rewrite those and just drop it. Plus or minus 2 square root 2. Last thing, move the 3. 3's cancel. You get x is equal to. Remember, I don't like the root to come second. So I'm going to put the -3 first. Then the plus or minus, then the 2 root 2. That is my answer to this question. So that's one way to solve for x. You're kind of factoring, but it's got to be a square. Now we have a couple practice problems on this because it does take practice. All right, let's move on. So let's take a look at question number 5. Question number 1, we want to complete the square. So same process. I'm going to go through this one just a little bit faster. Move the constant to the other side, just to get it out of the way. It's the only reason. So the 5 is going to get subtracted to the other side. All right, with the stuff on the left-hand side, create a square, not a rectangle, a square. You want it to be same base, same height. Put the x squared where it belongs. Take the x term and split it in half, perfectly in half. So negative 4x cut in half is negative 2x. Use what we know about the diagonals multiplying. So if I multiply the negative 2x and negative 2x, that's going to give me a positive 4x squared. So that diagonal is a positive 4x squared, which means the other diagonal is going to have to be a positive 4x squared as well. So find the thing that makes that happen. It's a 4. Now the 4 was not there originally, so I'm back to the equation. X squared minus 4x is equal to negative 5. You need that 4. So we're going to add that 4 to each side. Solve. X squared minus 4x plus 4. Add those together. That gives us negative 1. We'll come back to that in a second. Back to the boxes. Now let's factor. X minus 2. These better be the same dimension since we made a square out of this. So this is x minus 2 squared. This is x minus 2 squared is equal to negative 1. At this point, we would start peeling away the things around the x. So I have to get rid of the squared. So to get rid of the squared, I'm going to square root each side. Don't forget the plus or minus in front of the side that doesn't have the x's on it. Now let's take a look at this. The square and the square root cancel on the left. That was why we did it. We get x minus 2 is equal to plus or minus the square root of negative 1. You and I are going to come back and revisit this problem because at this point, that is not something we can do yet. We will very, very soon. So at this point, I have no real solution. But this will be something that we revisit in the future. Okay, question number 2. Why don't you see if you can get this all set up and all the way down to the end? Follow the exact same process. See if we can answer this one. Okay, so here I've got it worked out, but I didn't box this answer yet because you can actually add them together. And so we need to do that. We're running out of a little space down here. So I want to go ahead and add them. So one of them is going to be 1 plus 2. That's going to give me 3. The other one is going to be 1 minus 2. It's just splitting up that plus or minus part, and that's x equals negative 1. Now I have the answers. And don't forget, we're going to come back and revisit question number 1 in our very, very near future. Okay, got a couple more examples. Hold off on doing number 4 just yet. I want to talk through that one with you. But question number 3 is just like question number 2. So why don't you give it a shot and see if you can finish 3 all the way through. Okay, so there's my work for question number 3. Same process the entire time. Whatever I needed, so remember, move the constant, just get it out of the way. Whatever you need to fill in that top box where the constant goes, that's the thing you're going to add to both sides. And then when you do factor this, It has to be a square, so you got to make sure that the base and the height of this thing match. If they don't, you didn't complete a square. You maybe created a rectangle, but that's not really going to get us what we need here. And then I was able to square root 1 as positive and negative 1, which means you could then be able to add them together at the end. Okay, question number 4. We're going to start this the same way, so we're going to move the 7 to the other side for sure. So let's go ahead and rewrite this as 2x squared plus 4x equals 7. Basically, whenever you have a coefficient on your x squared other than 1, even if it's -1 or 5 or 7 or -2, it doesn't matter. You're going to want them to be just a single x squared. So this tells me, so this 2 in front tells me how many squares I'm going to make. So I'm actually going to have to make 2 of them here. So what I'm going to do is I'm going to set up 2 squares. Now, I want the 2 squares to be identical to each other. I don't want them to be any different. So I'll set up 1 square here, identical to the other square right next to it. And I'm just going to go ahead and put my spots inside. Remember, we're ignoring the constant, so just leave it out of it. And we're going to split the x squareds and the x's evenly amongst the 2. So there's 2x squareds, so each one gets 1. There are 4 x's total, which means we want 2 x's in the one on the left, so 1x and 1x, and then the other 2 x's on the one on the right. So if you go through and you add all of them as like terms, you should get the 2x squared plus 4x. If you didn't, you made a mistake when you split them evenly. Okay, so 2 of these squares, but we want the 2 to be identical to each other, which they are so far. Okay, so now let's figure out what the number is to make these. So remember that we multiply the diagonal. So if we multiply this diagonal, we're going to get a 1x squared. All right, so I think the only way that's going to happen is if that's a 1. Likewise, this better be 1x squared because they're identical to each other. So that needs to be a 1. All right, we'll come back to the boxes in just a second. Let's go back to the equation. So we have our 2x squared plus 4x is equal to 7. Now, between the 2 boxes, I added a 1 and a 1. Yeah, okay. So I added 2. All right, let's see what happens here. So that's going to give me 2x squared plus 4x plus 2, and that's going to give me 9. All right, now back to the boxes. Remember, we still have to factor. So I know that's x plus 1, x plus 1. All right, so from the box on the left, I have x plus 1 squared, okay, plus the box on the right. X plus 1, x plus 1. Okay, so I have another x plus 1 squared. All right, but look at the left-hand side. This x plus 1 squared is identical to this one. So I technically have 2 of those, technically. So I'm going to have 2 of the x plus 1 squareds equals 9. All right, not ideal, but we're coming in on the home stretch. Okay, so we were able to complete the square, which we did. We need to be able to solve for x, but it's not the squared we're going to get rid of first this time. We have a whole bunch of stuff we have to peel away. So starting at the x, the closest thing to the x is the plus 1. So that's going to be the last thing that goes away. The next thing is the parentheses. So that's going to go right before the 1 goes away. But then we also have this squared. Okay, so the squared's going to go before the parentheses, which is before the 1. But we still have this 2 kind of hanging out in front. The 2 is the last thing that's attached to the x, which means it's the first thing that's got to go. So I have to get rid of that 2. It's currently being multiplied. We're going to have to divide it. All right, so 2 divided by 2 simplifies. All right, now I have x plus 1 squared is equal to, I'm just going to leave it as 9/2. You can turn it into 4.5 if you want. I'm not going to. So I'm just slowly starting to peel my stuff away. All right, now it's the squared's turn. So to get rid of the squared, you know we're going to have to square root both sides. Don't forget the plus or minus in front. Okay, the square and the square root cancel on the left, so I get x plus 1 is equal to, whoops, drop the parentheses. Although, I don't really need them anymore, so I can actually drop them now. All right, let's get rid of them. Plus or minus square root of 9/2, or square root of 4.5. Last thing, let's move that 1 over. Those cancel, get x is equal to, you know I don't like putting that number second. I'm afraid it's going to sneak inside. Now, if I knew what the square root of 9, actually I don't even know if I do. Let's see what the square root of 4.5 is. Oh no, I don't want to do that. That's an approximation. Now, if I want an approximation, sure. But I think I'm good with an exact answer. And I think that we have that now for this question.